This is Professor Corey from the Professor's DuBois channel. In this video is a mini lecture version of our second lecture for Chapter 14, Chemical Kinetics. Previously, we discussed collision theory and reaction rates. In this lecture, we will learn how to write a rate law expression. Sometimes it's simply called the rate law. This equation will represent the relationship between the reaction rate and the concentration of the reactants. All rate law expressions will begin with rate equals K, followed by the reactants in brackets. The brackets indicate that we're using concentration, usually in molarity. The exponent associated with each reactant, labeled X and Y in this slide, are the reactant orders. Reactant orders have nothing to do with the balanced equation, and they must be determined by experiment. The reactant order represents how much the rate is affected by the concentration. As you can see with the general reaction, all that goes into the rate law from this reaction is the concentration of the reactants. We're not concerned with the products or the coefficients. There can be many reactant order possibilities, but we're going to focus on 0, first, and second order to get started. Two experiments are needed to determine the reactant order. The general reaction given has only one reactant for simplicity. For the first experiment, we have a known concentration of the reactant, we're calling that A, and we measure the rate. The second experiment will have a different concentration of A. Let's say it's doubled, and again, the rate is measured. If doubling the concentration of reactant A does not change the rate, we say the order of the reaction with respect to A is 0, or 0 order in A. Anything to the power of 0 equals 1, so our rate law would simply be rate equals K. In this scenario, we double the concentration of the reactant A, and the rate also doubles. This is first order in A. Our rate law can be written as rate equals K times the concentration of A, or A with the brackets around it. In this scenario, we double the concentration of A, and the rate goes up 4 times, or it quadruples. This would be second order in A. Our rate law would be written as rate equals K times the concentration of A squared, or to the power of 2. A brief summary. Notice how A to the 0 equals 1, so rate equals K for a 0 order reaction. As I stated previously, there are many orders, but we're going to focus primarily on 0, first, and second order reactions. If there's more than one reactant, we have to do more experiments. We will need to keep one reactant constant while we change the other, so we can be certain that any changes in the rate are due to the change in the concentration of just one of the reactants. The overall reaction order is simply the sum of all the orders. This example has 2 reactants, both are first order, so the overall order for the reaction is 2. For this scenario, our rate law would be rate equals K times the concentration of B squared. The A we can leave out because it's 0 order in A, and anything raised to the power of 0 equals 1. This makes sense because we determined that the reaction was 0 order in A, which means that the rate is not affected by the changes in the concentration of A. The rate constant, K, lowercase k, has units that are not consistent for every reaction. The units change in order to make the unit equal with the rate units. For a 0 order reaction, rate equals K. So the units of K have to be the same as the rate units. The rate is usually measured in molarity per time, but there are some variations, and those are noted here. For a first order reaction, we have our concentration units from A, so the units of K are just time to the -1, or 1 over time. For a second order overall reaction, the units of K are 1 over molarity times time. This is because we have to cancel one of the molarity units from the reactants. Remember, the units have to be the same on both sides of the equal sign. A useful equation for the units of K is the concentration to the 1 minus the overall order times time to the negative 1. That wraps up the second lecture, where we have introduced how to write a rate law expression. In our next lecture, we will go into more detail and include the method used to calculate a value for k. Stay tuned.